Now we'll briefly go over the site analysis presentation. The site is the other or the second important component of the project. As much as the program is important, the site is also important. And the relationship between the site and the program are the success of any design. So understanding the site and analyzing the site is a vital step in the design process. So you need to think about its conditions, its surroundings, its components, and its potentials to produce a certain design or a certain context for your project. And its relationship to the program, the environmental impact on community, adjacent properties, project budget, schedule, all these are important considerations when you think about the site. So when you think about the site, you need to identify its environmental characteristics, how does it accommodate the required program, what are the constraints and opportunities that you can find in the site. Again, the amount of time you spend in the site analysis is a essential foundation for cost-effective, environmentally sensitive, and rational approach to the project development. So this pre-design stage, as we call it, the program and site analysis, is very critical for the success of the project. Any missing information, any missing opportunity here will be translated into cost later. So we look at the site considerations, sun, wind, views, topography, soil type, vegetation, precipitation, noise, and so forth. So you identify the site location, and there must be some access road to your site. If there is no road near the site, there must be a road coming from the closest road. The types of winds and their direction, where is it coming from? The views, what will you see from the site, so that this will affect the design of the design decisions that you take later. The topography of the site, is it a flat site or a mountain, or has topography that you need to consider? And the topography, of course, is an illustration of the actual conditions of the land that you are using. So this is an example of a contour line that you might get from the surveyor, and each indication tells us about the different types of the slopes that are in the site, whether it's a convex or concave or valley or ridge or uniform slope. So each line of these lines represent a different condition of the site. So what do we do when we have a site with contours? We might design directly on the site as it is, or we can change some of the contours to create more flat areas for our design. طبعا site grading is the first step that we do during construction. So we can create a suitable area for the foundations and the structural system. The soil types are important, and we get a soil report in the beginning of the project. It tells us what kind of soils do we have, and whether they are appropriate for construction or foundation, or do we need to replace them with more appropriate material. What is the rock bed level, or what is the underground water level. All this information is important before we start our work. Some soils, they can create problems after construction if we don't consider them during the design. So soil reports tell us about the bearing capacity, the subsurface water, the ability of the soil to withstand seismic forces and so forth. And we have four basic types of soil. We have gravel, sand, silt, and clay. Sand is the most uniform and appropriate soil for construction. Gravel are big particles. They have good bearing capacity, but difficult to deal with. Sand is the most appropriate in terms of bearing capacity and drainage. Silt is very problematic because it swells when it gets wet. And that creates instability in the structure afterward. Clay is also problematic because it has poor drainage capacity. So it does not let the water go through it easily. So when we get the soil report from the soil mechanics, we get information about the depth of bedrock, if there is bedrock, the water table level, the bearing capacity of the soil, so that we understand which parts of the site are more appropriate, the expansive nature of the soils, which is very critical and dangerous, a location of any fault lines, soil types underground, the optimum moisture content for compaction if we are going to replace the site, percolation rate, penetration rate of the soil, and if there is any contamination with hazardous material. All this information has impact on the design and the construction. Do we need to have engineered fill? Do we need to consider the building form with the soil types, the types of foundation and structural system, erosion potential, drainage, runoff? All these are implications that happen from the soil. You all know the climatic conditions, the sun angles in the summer and winter, and how to illustrate that properly in drawings. Please illustrate the sun angles properly, site analysis. Not that smiley face that we usually get in this part. There are solar position charts that we use to understand the angles and the directions of the sun, so that we orient the building towards the proper orientation that we want. North, south, east, west, and how to design the building facades and building envelopes to correspond to these angles. There are websites that allow you to find information easily. This is the solar pass of Jeddah. that indicates the summer and winter path of the sun. This was the time and date when I generated this diagram. طبعا you can have it at different scales on the map. There are also climatic charts that are available online that provide you with information about the daylight, the temperatures, the wind rows, directions, and all this. Just briefly to go over the parking requirements, because in many projects they create problems. We have to understand that the parking takes more than just the space of the car. We need space for roads and sidewalks and curbs and stuff like that. So the car, depending on the size, takes about 30 to 40 meters in order to provide areas for the driveways and the landscape and access and entrance and exits and so forth. So when we talk about parking, we talk about the whole thing, not just the place or the area of the car itself. So all this site analysis information that we get as conceptual sketches, we try to interpret them and understand what is their implication on design. So it's not enough that you provide information. You need to analyze the information and find how does it impact the design. So for example, this is a site, and this is the site analysis where the topography is studied, the sun angles and wind directions, and then you provide suggestions for the zoning and views from the site. So the first thing is that you do is that you select the site, appropriate size, depending on the use and the program requirements. So that's why we start with the program analysis in order to understand how much site do we need. The site location, configuration, topography, access, and any adjacent environments or buildings or utilities around the site. طبعا the site coverage is also an important consideration, and this is affected by three factors: the total gross area of the building, and the number of floors, and the configuration of the building. How will it fit in the site that we select? The FAR ratio is the relationship between the site area and the square meters in the whole building. So the number of square meters that you can use on a building, it depends on the size of the site itself. So in this example, if the FAR is 2, it means that for a site area of 30,000 square meters, we can have 60,000 square meters of building. Building coverage is something different. This is the amount of area that the building can use from the site itself. So if the site is 30,000 square meters and you are allowed to cover only 50% of it, then the footprint of the building will be 15,000 square meters. Building height is another thing. It might be 2, 3, or 4 stories. And this is another variable that affects the building design. And it can be measured from the first floor elevation or the average grade around the base of the building. So this is a typical summary of what you can produce in terms of the site analysis and site use, depending on the program. So you understand the total site coverage, how much parking you need, how much utility easement you need for access and exit of utilities, how much open spaces and courtyards, and the building footprint. So the building can be 6, 10, 20 floors on this part of the building footprint. So these are some examples of sketches. Again, sketches are important. And I want you to produce most of the documents for this internship week at least as freehand sketches. Don't use computers, please. Forget about the AutoCAD and Revit and all that stuff. Use your sketching. This is an opportunity to improve the quality of your sketching. So the site planning, after we finish the site analysis, we go into site planning. We need to understand the services, the circulation, the zoning, the mass and spaces that will be on top of it. So these are the different layers of the site plan. As I said in the beginning, the site and program must be fitting for each other. They must be right for each other. So when you, after you think about the program and the site, make sure that the site and the program are fitting. If you select a site, you can review the program and change the program to fit the site. So they both must be related to each other. Site analysis and site selection also can be a job by itself. Some clients might have a site and they don't know what to do with it, so they ask you to develop a program for a site. And other clients might have a program and they don't know where to build it, so they ask you to find a suitable site for it. So again, this can be a job by itself. It can be a work by itself. So your service will be to evaluate the site and develop the constraints and opportunities. The client might have more than one site, so they ask you to help them select the appropriate site. So you need to think about the infrastructure characteristics and information about the zoning regulations and the number of floors, the FAR, the building footprint allowed. So all these variables can affect your decision in selecting a site. The size of the site, anticipated use, programming requirements, all these are important considerations in selecting the site. Now, to do this job, you need to think about the program. So you need to quickly develop a program for the project and select different ideas of how to accommodate the requirements of the project in that specific site. So you need to provide a site inventory and analysis of its physical, cultural characteristics, site evaluation, and collect all the information that you know, you need about the site. And the most important thing is a site visit. If you want to really know about a site, you must go and visit. Don't just depend on the analysis that you do in an office. So as we talked about the program as a document, also the site analysis is another document that you can provide to your client. You make a preliminary assessment and prioritize the site requirement. Then you make a site analysis, and then it has to be approved by the client, so that you don't waste your time without getting a compensation for it. So the site evaluation is done through assessment that includes all the physical testing of the soil, of the conditions, of the materials, and so forth. So you write a report at the end of the site analysis that has the property maps, geotechnical maps, site analysis recommendations, a statement about the impact of the findings, and recommendations for the proposed building program. So any project can start from the site or can start from the program. And you as an architect should be able to deal with both conditions. So if you have more than one site that you want to select from, so you can develop a selection criteria and assess each site according to this criteria. The skills that you need to achieve this is that you need to know about the climate analysis, topography, how to read soil reports and soil characteristics, to understand the utilities, the natural features and surroundings, transportation and access, historical conditions and landmarks. So again, as much as you can be a programmer, you can be someone specialized in the site analysis, in the site design, real estate evaluation, programming for the site surveys, market studies, economic evaluations, and land use studies. So we need to think about all the elements of the site and provide a full report for the client to understand what kinds of information is needed and what to expect from that particular site. So these are some examples of site utilization and your analysis or your suggestions for the use of the site and how it affects the plan of the project.